Alright student, let us start today's topic, that is probability, and probably one of the most important topics in the entire maths and the most relevant topic which you will use in your daily life to life. Alright, so we have split the topic into two lectures, lecture 1 and lecture 2, and we'll be covering lecture 1 today. Alright, so let's start the topic. So in this particular lecture we'll be covering basic questions using permutation combination, Venn diagram concept of mutually exclusive and independent events. Then we'll also be covering conditional probability, multiplication theorem, which are basically one and the same stuff, and we'll also talk about probability, total probability. So we'll consider the base and the other remaining concepts in the other lecture. So this is what we are going to cover in this particular lecture. Let's start with the first part, that is the basic questions using PNC. So let us start with a very basic question, that is if a leap year is selected random, what is the chance that it will have 53 Tuesdays? Very basic problem. So first of all, we just have to understand when the questions are based on PNC, permutation combination, you have to be very sure about what will be the sample space. Okay, so if we talk about a year, right? Let's talk about a year. So year has how many weeks? Year has 52 weeks, right? Every year we have 52 weeks, which is nothing but which reduces to 364 days if you talk about this way. Okay, and in the leap year, if I talk about the special case, that is the leap year has how many days? Yes, it has one extra, that is 366 days are there in the leap year, right? So that is, this implies 2 days extra, right? So what is the sample space in this particular question? Can you tell me? If a leap year is selected, what is the chance that it has 53 Tuesdays? You want that, obviously 52 Tuesdays will be there. That is not a question. 52 Tuesdays will definitely be there. You want instead 53 Tuesdays. That is your target, right? So that means in these 2 extra days, 1 extra day should be Tuesday. But what is the sample space now? Can you think of what is the sample space be like? Okay, I'll give you the idea what is the sample space in this particular question. So it says that 2 days are extra. So can you now start and tell me what are the 2 days? So let's say it could be a pair of Sunday, Monday pair, right? It could be Monday, Tuesday pair. It could be Tuesday, Wednesday pair. It could be Wednesday, Thursday pair. It could be Thursday, Friday pair, Friday, Saturday. Getting my point? And it could be Saturday, Sunday pair. So how many pairs, extra pairs are possible? This is what is my sample space in this particular question. So if you want 2 days extras, these 2 day extra options are there, right? How many options? 7 options are there. Can you see this? Just count, there are 7 options. So I would say my sample space in this particular question is 7. Out of which, how many are favorable? So what is probability? Yes. So I have actually left the what is probability? Probability is nothing but favorable cases. That is the cases which you want divided by total ways in that event can be done, total ways, yeah, or we can say the sample space as well. So we want the favorable cases, that is which are favorable to us. You want Tuesdays, so Tuesday is here and the other Tuesday is here. So out of these, 2 are your favorable. So the answer is nothing but 2 by 7. This is the answer we were looking for, as simple as that. So if you are clear with the sample space concept, believe me, the questions which are based on PNC will be a cakewalk for you. Okay. Now let's take another question which says 6 dice are thrown simultaneously. So whenever I say that 6 dice are thrown, so immediately what clicks to my mind is the sample space, which will be 6 raised to power 6. This is now I can say immediately. Then the first part says that find the probability that all of them show the same face. So let's take it as a dash problem, as we have done in PNC, right? So 6 dashes, each one for dices 1, 2, 3, 4 and 5 and 6, right? Now you want that each of them show the same face. What will happen then? Let's see. So dice 1 can take all the 6 numbers 1, 2, 3, 4, 5, 6. But then dice 2 cannot have more than one option. Why? Because it will repeat the number which is coming on dice 1, because you want dice 2 to show same number as dice 1. Similarly for dice 3, dice 4, dice 5, dice 6. So all of them, these 5, do not have any other option but to show the same number which is coming on dice 1. So the total number of options that you have is 6. Sample space is 6 raised to power 6. The answer to this particular problem is yes. This is the answer. Let's quickly talk about the second part now. All of them show different faces now. Now you want these 6 numbers which will be represented on the dashes to have different numbers. So how do you differentiate then? Let's say we start from dash 1 again. It can take any 6 numbers. Then yes, D2 will have only 5 options available because it cannot take the number which is coming on dice 2. For dice 3, it cannot take the number which is already there on dice 1 and dice 2. So this is how you will do. This is nothing but 6 factorial divided by 6 raised to power 6, which I don't think you need to further solve. Alright, you can just skip it here itself. Let's take the third part, which is the most interesting part of this particular question, right? So it says exactly 3 of them show the same face while remaining 3 show different faces. This is pure PNC based problem, right? It's not a probability question at all. So it says out of these 6 spaces, let's say these are the 6 spaces, 3 show same number, 3 show same number, right? Okay, and 3 show different number. Okay, so now there is an option that how you are going to attempt this particular problem. So when you say 3 show same number, that means you have to select which number is getting repeated. How many numbers are there? 6. So out of these 6, 1 would be there which will be repeated 3 times. So we can select it in 61 ways. 3 show different numbers. So already 1 is being selected. How many numbers are remaining now? 5 numbers are remaining. Out of those 5, you want 3 more to be selected. So that is 5C3, of which all of them are to be placed on 6 dashes. So now we have 6 numbers, right? So in fact, you can see here that it is 6C1, but it means you have selected 3 numbers because all of them are same. So selection has been done, 6C1 into 5C3. Now they can be arranged also. How many numbers are there? Total 6 factorial. 6 numbers, so total number of arrangements could have been 6 factorial. But out of which how many are repeating? They show the same, so identical numbers. So yes, remember mathematics word. So 6 factorial by 3 factorial. This is the answer of favorable cases. So what is probability, right? You must have done, I have actually skipped the very basic of probability. Probability is nothing but favorable cases, the cases which are required divided by total ways, right? Total cases of doing that particular event, whether favorable or not favorable. So you will divide this particular event by 6 raised to power 6. That is your sample space. This is the answer we are looking for. Okay. The fourth part is completely same. So I am just leaving it for you guys. So it says at least 4 of them show the same face. So at least 4. So at least 4 is nothing but it is a bit lengthy question. At least 4. So you will solve it for 4. Then you will solve that at least all 5 cases are same. And then you say 6 faces are same. So at least 4 will be what? Again 6C1 into out of 5. Now you will just need to select 2. Then in out of 6 factorial, 4 are yes repeated. Plus for 5 what you will do? Out of 6 C1 you will select the one which will be repeated 5 times. Then out of 5 you will just select 1 and then you will say 6 factorial by 5 factorial. And this is what? All of them are the same which you have already done. That is what it will be 6 upon the same stuff which we are going to do, that is whole divided by 6 raised to power 6. So this is the answer for the fourth part. Alright. Okay, now let's take a problem which has been asked in JEE Mains as well. It says a 2 cross 2 square matrix. Now we know that what is a 2 cross 2 square matrix? Something like this, which will have 4 numbers A, B, C and D, right? So 2 cross 2 will have how many numbers? That is yes, 2 cross 2 will have 4 elements, which we have taken as to be A, B, C and D, 4 elements. And the elements that are being used are nothing but 1 and minus 1. So elements have to be formed using minus 1 and 1 only. You cannot have any number other than 1 and minus 1. Find the probability that the matrix is non-singular. So what do you mean by singular and non-singular first of all? So now the pattern. So if I talk about the pattern of the examination, this is how the pattern has actually changed. So now they have started asking questions which are comprising of concepts from different chapters. So for example, singular matrix is basically from the topic of matrices and determinants, whereas it has been clubbed with a question of probability. So this is the trend right now with JEE. This is very famous trend. For the last 3 years, if you see, this is the trend going on. So for singular matrices, it is that determinant of the A matrix should be 0. And the non-singular would be then, so for non-singular matrix, the determinant of this would be not equal to 0. Now, first of all, again, we'll talk about the sample space. So whenever we talk about the probability question, so we need to talk about the sample space. So you have 2 elements, right? And you have a 2 cross 2 matrices. How many matrices are possible, right? So for example, let's again put the dash. So these are the 4 dashes. And how many ways each dash could be filled? Yes, in 2 ways. So what is the total number of matrices that you can form is 2 raised to power 4. That means 16 is the sample space. 16 total matrices are there which will be having elements as 1 and minus 1 only. Now you want how many of them are singular and or basically non-singular, right? So let's talk about the non-singular one, because you won't need to find the non-singular, or you can also find the singular, and we'll do the reverse method. So singular matrices, right? And then we'll find singular matrix and then we'll subtract it from 16 to get non-singular matrices. Can you tell me how you can find the singular matrix part? Let's take an example to understand it. It's a hit and trial method. So 1, 1, 1, 1. Is it a singular matrix? Obviously, because the determinant is 0. Now let me take another one. Is it a singular matrix? Yes, it is. Why? Can you see the pattern here? The diagonal elements are same, right? So similarly, I can say and make another one where diagonal elements are minus 1 and minus 1, 1 and 1. So this will also give you value 0. Here also the pattern was that all 4 elements are same. So there can another be written something like this, right? Again, the determinant will be 0. Let's take another one now. Tell me the answer for, let's say, this. Here the second column is same. Yes, answer is 0. So if this for second column it is 0, so then I can say for first column also will be 0. Similarly, if it is happening for column, then it will happen for row as well. So minus 1 on the first row, 0, and again it could be repeated for row 2, right? So these are the 8 cases which will make it singular. 8 cases which will make it singular. Any other case that you take will make it non-singular. So non-singular, you can say how many non-singular matrices are there then? So non-singular is nothing but 16 minus 8. This is equal to 8. Then what is the probability? Yes, so the probability is nothing but we wanted the favorable cases to occur. So probability is 8 by 16, which is nothing but 1 by 2. This is the answer which we were trying to find. Let's take a question again which comprises of quadratic equation and a mix of probability. It said 2 numbers B and C are chosen at random with replacement from first 9 natural numbers. So for example, B and C must belong to then this set of numbers, right? They to go still 8 and 9, right? Okay. Find the probability then that x square plus bx plus c is greater than 0 for every value of x belonging to R. So now this is a quadratic. When does a quadratic is always positive? So now the concept has to be checked. This is how quadratic can be checked in the exam. So this is always greater than 0, always positive, right? This is happens only when a is greater than 0 and d is less than 0, right? Remember? So here a is already positive. What is the value of d that you will get? D is nothing but b square minus 4c, and you want this to be less than 0 for this particular condition to be true. So again, first of all, let's talk about the sample space. We forgot to talk about the sample space. What is the sample space? Can you tell me? How many numbers are to be selected? 2 numbers, that is B and C. What are the options for B? 9 options. And it is said that B and C are chosen with the replacement. So that means if you choose B as 3, you will pick B 3 and then put the value of 3 back in the bag. Then you put then you select C. So for again C, how many options are there? 9. So the sample space that you people are checking is 81, right? Now you want those values of B and C for which B square minus 4AC is, or in fact 4C is less than 0. Or in a way you can say that B square is less than 4c. This is the value that you people are looking to find. So let's draw a table to understand the concept. So let's start with b equal to 1. So when b is 1, b square is 1. What all possible values of c will make 4c greater than b square? So if I say c is equal to 1, so 4c is 4. Is 4 greater than 1? Yes, so that means this is our answer. So that means if you say 2 also, so let's say 2 will also satisfy because it will make it 8. 8 is greater than 1. So how many values will satisfy when b is equal to 1? So c can take all the 9 values, right? Got it? So these 9 cases are your favorable cases, that is b is equal to 1 and c is equal to 9 values. So how many cases here? 9 cases. Let's put b is equal to 2. So then what will be the value of b square? So now b square is 4. So what is the value, minimum value of c that will satisfy now? So people say, sir, 2, right? So 2, absolutely correct. If you put c is equal to 2, what will be answer? 4c is 8, which is greater than b square. So when b is equal to 2, c can take values from 2, 3 up till what particular range? 9. How many options now? 8 options. Let's put b is equal to 3. This implies b square is equal to 9. What is the minimum value of c that will satisfy now? Right, c will be 3 now. So when b is equal to 3, c will start from 3 also. So 3, 4 up till 9, that is again 7 values. Now let's put b is equal to, we'll take b is equal to 4. This implies b square is equal to 16. You want it to be that 4c should be greater than 16. So what is the minimum value of c that you will start from? Yes, from 5, not from c should not be equal to 4, because it will make, if you put c equal to 4, it will be 16 equal to 16. We want 4c to be greater than 16, not equal to 16. So 5, 6, 7, 8 and 9. So how many cases there? 5 cases are there. Then we put b is equal to 5. b is equal to 5 will convert this into b square is equal to 25. You want this to be less than 4c. So what is the minimum value of c that will satisfy this now? If you put 5, you will get 20, not acceptable. If you put 6, then it will be 24, not acceptable. Yes, so the value of c should start from 7 this time. 7, 8, 9, 3 cases. Let's put b is equal to 6. This becomes b square is equal to 36. It should be less than 4c. What is the minimum value of c that will satisfy now? We have checked till 7. 7 is 28, 8 is 32, 9 is 36. In fact, here is no value. B is no value, right? Or you can say B belongs to 5. Why? Because we cannot say C is equal to 9. Why? Because at C equal to 9, this will be equal to 36. We want greater than 36. So how many answers then? Yes. So these are 9 values of B and C, 8 values, 7 values, 5 values and 3 values. So if you add them, all of them, then the answer would be, how many cases are there? So 15 plus 5 plus 3, 20, 32 cases are there which are favorable, divided by your sample space 81. This is the answer we were looking for. For that means the probability that this quadratic will be positive for every value of x and b and c will be 32 by 81. So now let us understand the concept of Venn diagram. So I am taking a Venn diagram first of all when 2 events are there, right? For 2 events, right? 2 events that are A and B, right? And they are not disjoint. So what do you mean by disjoint? That they do not intersect, right? Disjoint means that A intersection B is null set. Okay, so if they are not disjoint, A is here, B is there, and this is their common region, right? Which is the shaded. So let's say this is region 1, right? Region 2, and this is region 3. So actually it divides the sample space. So this rectangle is the sample space. So how do you have to read it? They are, of these sample space, there is one event A, there is one event B, and there is a possibility that both can occur together, and there is a possibility that both A and B do not occur, which is this outside region. Okay, so the third region, that is both occur, right? They both occur. How do you write it? Actually is P A intersection B, right? Probability that both of them occur is this, and you can also write this something as N of A intersection B divided by NS. So n is nothing but number of elements in A intersection B divided by number of elements in the sample space. If I talk about this particular region, that let's say I shade this also, and this also. That is the entire 1, 2 and the 3 region. So what it will represent? It will represent A union B. Right? And we know the formula for A union B is nothing but PA plus PB minus P of A intersection B, right? Obviously, why we are getting subtracted A union B, A intersection B is because it is added 2 times. It is also in A, it is also in B. You want only one, so we'll subtracting it once. Okay. And more importantly, this has to be expressed as, if somebody says that at least one of A or B occurs, right? If something, this statement is given to you, this means actually you are trying to find A union B. Please remember this, very important stuff. A union B means either one of them occurs or both of them occurs. This is the meaning of A union B. So what you have to understand of A union B is at least one. This is what is meant by this, at least one. So since there are two events, so it could be one or it could be both the events, right? How we represent this? Only A. So this means only A region, that is only A, probability only A. So this is represented something like probability of A intersection B bar. B bar is when you do not want B, and the value of this is PA minus A intersection B. That means you want to remove this 2 region from this bigger circle. That means you want only the first region. So answer for the first region is 1 plus 2 minus 2, obviously. Similarly, you can find probability only B, right? Probability only B, which will be nothing but probability B minus probability A intersection B. Got it? And this is what is this region? Can you spell it out? What will be this? Yes, this is called exactly one of them occurs. Exactly one of them occurs. That means both does not occur. That is why I have left this region. So this is written as something A intersection B, that is only B, union or plus, you can say probability A does not occur but B occur, right? This is what is meant by this. So what you will do, you will just add these two. So what answer you should get is probability A plus probability B minus 2 times A intersection B. So this is how Venn diagrams are used. If you understand this, all 5 diagrams, believe me, you will be able to solve all the questions based on 2 event Venn diagram questions. Okay, now let's consider the case of Venn diagrams when 3 events are there, that is A, B and C, as it is there on your screen. So this particular diagram says A is also shaded, B is shaded and C is shaded. And if you clearly see, there are 7 regions. If I want to draw 1 region, 2 region, 3 region, this could be 4, 5, 6, and this middle region can be said as the 7th region. So there are in total 7 regions. You want the answer of all the 7 regions. So this is called probability A union B union C, right? And again, it is meant to say that at least one of A, B, C occurs. This is what is meant by this. So at least one of them occurs means 1 can occur, 2 can occur, or all the 3 can occur. That is why all the regions are shaded. What is this shaded region? 7 region. Region 7 is nothing but this is A intersection B intersection C. That is when all the 3 occur, right? We know the formula. Then if I want to write the formula, that A union B union C, right? What is the formula that you people know? Right. So it is NA plus NB. You can just replace P by N over here. Okay. So I'm just taking the normal formula, or you can just replace N by P. This is one of the same stuff. Minus NA intersection B minus NA B intersection C minus NC intersection A plus probability or N A intersection B intersection C, right? This is the answer. Okay, so you should remember this formula here. This is what? This is the category that I will talk about, only A, right? So what is, how do you write only A in when 3 events are there is something like this. A occurs, B does not occur, B bar, and C does not occur, C bar. This is how you represent this particular stuff in set notation. And if you want to solve this, what will be the value then? It will be, the value of this would be nothing but from complete A, you have to subtract this region 4 and you need to subtract this region 5. So 4 region is nothing but A intersection B, right? A intersection B, then minus 5th region is A intersection C, right? But you have subtracted this 7 region twice, so you will have to add this region, that is this answer. So this is how you find only A, probability only A. You can similarly find probability only B, probability only C. Let's talk about what this circle represents then. So this represents exactly one of them occurs, right? One of them occurs. And how do you write it in set notation is probability A occurs, intersection B does not, intersection C does not occur, plus, yes, probability this time A will not occur. You want B to occur, but C does not occur, plus probability A does not occur, B does not occur, intersection C occurs. And what you will do, you will add the values that you will obtain here to get this particular answer, which I am leaving it for you guys. Okay, now this particular region in this particular diagram is, forget about that this is not here. All right, this is not here. So this means exactly 2 of them occur. Exactly 2 of them occur. So that means if exactly 2 of them occur, it means probability A intersection B intersection C bar plus probability, now A will not occur, B and C will occur, right? Plus you can say probability A will occur, B will not occur, but it will occur with conjunction with C. This is means exactly 2 of them occur. So what you will do, this region and this region, so this region can be written as A intersection B minus 7 region. This can be A intersection C minus 7 region. This could be B intersection C minus 7 region. This is how you find these values. And this particular diagram is known as at least 2 of them occur. So for at least 2 of them occur, what do you mean? Either 2 exactly, or 3, all of them, or basically all, right? This is what is meant by this. So this is the way of writing Venn diagram for 3 events. All right. The basic formula that you people still have to remember is this one. All right. Clear? Now let's look at basic questions which are based on combination of Venn diagrams and the basic stuff that we have done. It says 20 tickets are numbered from 1 to 20. One ticket is drawn at random out of these tickets. What is the probability that a ticket is a multiple of 2 or 5? So how you have to attempt and think of this is that there is an event A that is happening, which is the ticket is then a multiple of 2 for A. B event is when this is a multiple of 5. This is what we can say. You are said that the probability that ticket is a multiple of 2 or 5. So now this or is very important. So when you say or, so this means that you are trying to find probability that either A occurs or B occur or both of them occur. That is completely fine with me. We know that this answer is nothing but PA plus PB minus PA intersection B. This is important. Don't forget to do this particular step. Okay. So you want, what is the probability A? Event probability A that it is a multiple of 2. So there are 20 total numbers, out of which 10 will be a multiple of 2. So this is half. What is the probability of event B? That it is a multiple of 5. Yes, there are 4. So that is 4 by 20, right? Okay, so just start putting these values. I'll just write 10 by 20 here. This is 4 by 20. Why? Because it is taking LCM is easier. What is A intersection B? Probability A intersection B. So for A intersection B, just think of the elements which are common to them first of all. What elements will fall in here? Can you tell me? If I want to talk about the number of elements in A intersection B, yes. So it will be 10 and 20 only, right? Because 10 is both factor of multiple of 2 and 5, and 20 is also multiple of 2 and 5. So there are only 2 cases which are common in both of them. So this is the answer we guys are looking for. That is nothing but 12 by 20. This is the answer, or you can say 3 by 5. This is the answer we are looking for. Okay. Let's take the other problem. It says odds in favor of an event. So what do you mean by, first of all, odds in favor? Okay, odds in favor. This is also an interesting concept which is generally asked. So odds in favor is nothing but favorable cases divided by unfavorable cases. This is the only change, right? For probability, what you people used to do was favorable cases divided by total cases. Now what you will do, so unfavorable. So let's say there is an event which has favorable as f and unfavorable as u. So the total, this is the sample space, you can say. The number of ways of doing the event in is f plus unfavorable, so sample space. So our probability of occurring of event, if I talk about the favorable one, was f upon what? Yes, f plus u, whereas odds in favor is nothing but f by u. This is what is mean. And odds against, so similarly the concept is for odd against. Odd against is nothing but unfavorable by favorable. This is nothing but opposite of this. Okay, so this is what is given to you now. So odds in favor of A, odds, let's come back to the question, odds in favor of A. So that means if A has to happen is given 2:1. So this means favorable by unfavorable. And that means what can be said about the sample space? Sample space is nothing but 3. Though it is not exactly equal to 3, this is under the proportional terms. Why? Because just understand, we can say f is 2 lambda, u is lambda, so then sample space will be 3 lambda. So what is the probability of event A then? The probability of event A would be favorable divided by total, that is what? 1 by 3 or 2 by 3? Tell me. Yes, it will be 2 by 3, not 1 by 3, because favorable events are 2. Other thing that is given is odds in favor of A union B. Odds in favor of A union B. So A union B favor. So this means what can we what is given? First of all, 3:1. What can we say about then here probability of A union B? Yes, it is nothing but 3 by 4. Now you got the point how we are doing this. Okay, so this is odd in favor of A union B can be translated to. So let me just convert this into formula then. If it is given that odds in favor, right, odds in favor is equal to A by B, let's say, right? Let me just correct it. So remove this. If it is given that odds in favor is A by B, then probability of event A will be nothing but A upon A plus B. This is what you can say. All right. So now, but coming back to the question, so now you have two things. Let me just highlight them for you, that you have probability A, that is 2 by 3, and probability A union B, that is 3 by 4. Now using this, you need to find the range of the probability of event B. Now this is the question. How these things are interrelated? Now let's just combine them. So A union B is nothing but probability A plus probability B minus A intersection B. This is what is there. Okay. Now your target is, you want, what do you want? Let me just write it here. You want range of probability B. This is something which you want. So obviously when we think of range, always we think of inequalities, that somewhere inequality will come into picture, right? This is what I think generally of range. So how you can introduce a inequality? Can you think of this now? So just start putting the values. It says 3 by 4. This is nothing but 2 by 3 plus PB minus probability A intersection B. Okay, so if I solve this, I in fact intend to write something like this. PA intersection B is PB minus, if you solve this, this will come out to be minus 1 by 12. Alright. So now let's see how I am going to introduce the inequality portion over here. So you are talking about A intersection B. Can you tell me what will be the range of A intersection B? It could be that they do not intersect. So if they do not intersect, that means A and B are disjoint set, then their probability will be 0 because they are disjoint. That is a clear evidence that it will not occur, right? Then what could be the maximum value of A intersection B? Yes, it could be that the entire A is inside B, or the entire elements of A are common with elements of B. So the maximum possible way of saying probability A intersection B is probability A itself. This is where the inequality comes into the picture. Now I guess you must be able to understand how we are getting to find the range of PB. As simple as that. So now PA is nothing but, you already have calculated, this is 2 by 3. This gives you the range of PB, which is nothing but, if you want to get to the final answer, 1 by 12, and this is PB will be nothing but 3 by 4. So this gives you the range of PB, which we were trying to find. Alright, and remember this particular problem, very interesting problem, how you have how you find range of particular probability using A intersection B. Okay, now let us discuss something which you people have real confusion about, that is two cases, mutually exclusive and independent events. So what is a mutually exclusive case or a mutually exclusive events? If A and B are two mutually exclusive events, then the happening of A rules out the happening of B, or vice versa. So that means they do not occur together. They can never occur together. That is the meaning of mutually exclusive cases. So what do you mean by this is that, let's say if you toss a coin and you say that both head and tail occur simultaneously, it is not possible. So occurrence of a head or a tail on a single throw of a coin is basically mutually exclusive events. They cannot occur simultaneously together. Alright, so they are actually, in other way, disjoint set. So that is why it is written that A intersection B would be null set, right? Or if you want to convert this into probability, then probability A intersection B will be 0 if they are mutually exclusive events. So then what do you mean by independent events? Independent events are then if two or more events are said to be independent, the probability of the occurrence of one does not change the occurrence of the other. So see, generally I have seen people interchange these two concepts, or they are not properly able to distinguish these two. So it mutually exclusive says that one will override the occurrence of the other. Here it says it is irrespective, that whether A occurs, it does not affect the chances of occurrence of B. That is what is meant by independent event. And as the name suggests, they are independent. A and B are independent. That means if A occurs, it does not matter to B. If B occurs, it does not matter to A. So it will not change their respective probabilities. Whereas if I say mutually exclusive, if A has occurred, then B cannot occur. And if B has occurred, A cannot occur. So if in case of mutually exclusive, only one can occur. For independent, both can occur. That's not a problem. So in a way you can say, for mutually exclusive, they are interrelated. For independent, they are nowhere related. That is how you can understand. And the special formula, how you check whether the events are independent. So probability A intersection B intersection C is nothing but PA, PB, PC. And if say, let's say there are just two events, so this is what we are going to use. And this is also the formula that you can use to prove that events are independent or not. Okay. And if A and B are independent, then A dash, B dash are independent, A, B dash are independent, and A dash, B are also independent. Alright, so all these events will also be independent as completely written here, right? Okay. So to further elaborate on how do you differentiate mutually exclusive and events? So exclusivity, if I talk about exclusive events, right? Mutually exclusive. So mutually exclusive events occur in a single stage event. That is how I try and define it. Single stage event. Single stage. What do you mean by single stage? For example, toss of coin. Toss of a coin is a single event, right? And we talk about the head and tail of this particular single stage event. Whereas independent events, right? Independent events is a multi-stage event case, right? Multi-stage event, or you can say multi-level event. So multi-level event means that it will be occurring over a period of time. For example, now a single toss will not be done. Two tosses of coin will be done. Two tosses. This makes it multi-stage. So when you say toss 1, right, at toss 1 you are talking about, let's say, head will occur. At toss 2 you are talking about a tail will occur. So now these head and tail are called independent to each other. Now they will not be called mutually exclusive. Why? For mutually exclusive, they should have been on the same stage or the same level. It is toss 1, it is toss 2. Now we will say they are not, we will not talk about mutually exclusive. Remember, right? They are not mutually exclusive. We will talk about their, yes, whether the events are independent or not. So for independent, it has to be a multi-layered or a multi-stage event. For mutually exclusive, it has to be event from a single stage, from a single experiment. Got it? So let's take some questions on based on mutually exclusive and independent event. In fact, before we go further, we can also understand exhaustive events. So what do you mean by a set of exhaustive events is that if I say A, B and C are set of exhaustive events, then probability A plus probability B plus probability C should give you 1, that is sample space. That is a sure event. Or in a way, if A union B union C gives you sample space, then A, B and C are known as exhaustive events. That is what is the definition. Now let's read the question. For a post, 3 persons A, B, C appear in their interview. Okay, so there is one job which is there, right? And how many people are targeting? For this, 3 people are vying for it. 3 people, right? Which are namely A, B and C. The probability of A being getting selected is twice that of B. So probability A that it gets selected is twice of probability of B. And probability B being selected is thrice of, yes. So this is what is given to you people. Now let me assume that probability of C is X, right? Then what will be the probability of B? 3x. Then in return, what will be the probability of A getting selected will be what? Yes, 6x. This is what you can say. And you are asked to find their individual probabilities. That means you need to find, target is to find X, then only we can find their individual probabilities. So what actually relates to this question is that probability A union B union C. So what do you mean by this? That at least one of them gets selected for the job, right? And this is what is the target, that 3 people are contesting for an interview and there is only one job. This probability should be 1, that obviously out of these 3 at least one will be selected. What is probability A union B union C? What is this? So the formula for this will be probability A plus probability B plus probability C, and we know that this should have been probability A intersection B minus something like this. Okay, so if you notice that this is nothing but 0, this cannot happen, because since it is a single job, both A and B cannot be selected. There is one job and you are entitled to select only one person, so this is not possible. Similarly, this is not possible, this is not possible, and obviously all the 3 cannot be selected. This is not possible, so this is 0. In a way, this is called, they are mutually exclusive cases. Understood? So this question was based on mutual exclusivity, that only if A is happening, B cannot occur. If B has been selected, then C will not be selected, and if in the other way C is selected, then both A and B cannot be selected. So that means they are mutually exclusive. So the only problem is that this one will be distributed in PA plus PB plus PC. Now you know all these values it is given, that is 10x. So this implies 10x is equal to 1. X comes out to be 1 by 10. Now you can find their individual probabilities very easily. 1 by 10. Alright. So this is how you need to think on problems which are based on this level, right? Okay. So this is 6 by 10 and this was, sorry, PC, right? Just rectify it. Let's take another question. It says a candidate has to appear in an examination in 3 subjects, right? The 3 subjects are given to be English, math and physics, right? His entrances of passing his entrances, no, or you can say his chances here. His chances of passing in these subjects are, so English is 0.5, which is pretty good. Oh my god, pretty high for maths, and for passing in physics is 0.9. Alright, this means he's a very good student. He is just not studying English. And that is, in fact, I like about this chapter is that it is very much related to your real life. This is what actually happens in your day-to-day life, that you calculate your probability of passing into or getting into IIT, or let's say maybe in a particular subject. So this is where you relate to this chapter. You need to find the probability that he passes in at least one of these subjects. So now let me just first of all talk about what you interpret out of this particular question. He passes at least one of these subjects. So if you are not sure what this statement means, you will not be able to solve this further. We have done this, at least one is A union B union C, right? And we know the formula for this. So this is the formula that we have to talk about. So this here represents this particular statement that at least one passes. So A union B union C, one passed in one, passed in two, or passed in all three. All these cases are covered in this particular scenario. You need to find this. You are already given this is PA, this is PB, and the third one is your probability C. So these three events are done. So these three are given to you. Now you want to find these remaining cases. So it is given probability A intersection B. Now I can easily say that probability A intersection B is nothing but PA into PB, which is nothing but definition of, yes, independent events. Why they are independent? Tell me why they are independent. So whether you pass in English is related to whether you pass in maths or physics. Obviously not. So passing or failing of in English is not anywhere related to maths. Though on a psychological level you can say so that if you fail in the first and in the second, the probability increases that you fail in the third because of the mental pressure, but it is not nowhere given. We can take that into account if it was given in the question. That means they are independent events. That means it is nothing but 0.35, as simple as that. Similarly, PB intersection C is nothing but PB into PC, which we also know is 0.63, and for C intersection A it will be nothing but PC into PA, which we also know is 0.45. And similarly, we target A intersection B intersection C, then this value would be what? Yes, PA, PB into PC, all the three values multiplied. This comes out to be 0.315, right? Now I'm leaving the question for you guys, just you need to fill all these values. So you have what? 0.35, 0.63, 0.45, just put the values here and get this answer. Let's talk about the second problem B. So it says he passes exactly in two subjects. So now remember the Venn diagram that we did. So if this is the Venn diagram that these three subjects are denoted like this, so what is actually asked of you is that it exactly two subjects. So exactly two ranges this region, and this region. You need to find this, okay? And if I say that this is A, this is your B, and this is your C, so how you can relate this is, this region is A intersection B, but this is the seventh region, right? Region 7. So 7 is nothing but A intersection B intersection C, and let me call this as the fourth region. So fourth region you can say is nothing but probability A intersection B minus, got it? This is the shaded region that you want, fourth region. Then region 5, let me call this as region 5. So then what will be the region 5? Yes, probability A intersection C minus this particular again, right? And this, let me call this as the region 6. Obviously, now I hope that you have got the point what I'm trying to build here, right? So this is how you need to calculate this particular question, and you want all the three. So you want answer for region 4, 5 and 6 combined. So this gives you answer probability A intersection B plus this is what you will need to solve for this particular question here at hand, minus 3 times, and you already have calculated these particular values, okay? So just put the values to find the answer here. So this is the answer, okay? Now let's take the other problem. It says that A and B are independent even and they are related something like this, right? P A intersection B is equal to 1 by 6. The other relation that is given is in their complement form, right? 1 by 3. You are asked to find value of PA. So we know that if they are independent, yes, this property can be used, and since they are independent, I can still say this is yes, okay? So this is the region that this particular question might have been asked. So Now I guess this is pretty simple and straightforward question. Let PA be X and let's calculate PB be Y. So this comes out to be that XY is equal to 1 by 6, and what this value would become will be 1 minus X into 1 minus Y is equal to 1 by 3. So in fact it is nothing, it is basically a linear equation in two variables. So if you try and solve this, what it would become, let's see, 1 minus X minus Y plus xy equal to 1 by 3. I can say 1 minus x minus xy. If I send it over that side, it will be 1 by 6, and x plus y is nothing but 5 by 6. So this is my first equation and this is my second equation. You just need to solve them on the same side. So just solve them. I guess you people can do this now. So we just substitute the value of y, let's say. So this will be x plus what would be 1 by 6x, right, equal to 5 by 6. We can say this becomes a quadratic, that is 6x square plus 1 is equal to, we can say will be what, it will be 5x, and it is 6x square minus 5x plus 1 equal to 0. If you solve, what values of x you will get? Yes, so in a way you will get two values of x which is satisfying this, either this or 1 by 3. This is what you will get over here. And if you put x equal to 1 by 2, so for this correspondingly you will get y is equal to 1 by 3, and for this particular value the corresponding value of y will be 1 by 2. So there are two pairs. So you can say x is equal to 1 by 2 and y is equal to 1 by 3 will be one of the answers, or x equal to 1 by 3 and y equal to 1 by 2. So these both are your answers. Okay, just keep that in mind. Let's take other problem. It says there are three urns A, B and C. So let me have three bags. A bag, you have a B bag, and you have a C bag, right? A contains 4 white, so this has 4 white and 5 blue balls. Then the other it is given 4 white and 3 blue balls in the B, and in the C it is given to be 2 white and 4 blue balls, right? This is what is given to you guys. Okay, so now one ball is drawn from each of these bags. So you pick one here, you pick one from this bag, and you pick one from this. So this is the cases. In total you have selected 3 balls, right? 3 balls are selected in total. You need to find such that 2 are white, right? 2 are white and 1 is blue. So now first of all, why we have taken this question here, can you see that all these events are independent events? Because they are multi-stage events also. Why multi-stage? Because ball being taken from A and one ball being taken from B are completely independent. They are different stages. One is saying from bag A, one is saying from bag B, one is saying from bag C. So they are completely independent events. So why we have to do now is that 2 are white and 1 is blue. So 2 white, 1 blue, right? So how I am going to write this particular question is that I will say first bag intersection second bag, what color I draw from the second, and intersection what color I draw from the third. So for example, first case could be that I draw a white from first, white from the second, and third from the black. Plus, tell me the other case. White, black, white. Other case could be black from first, white from second, third again white. Any other case which I have left? So these positions actually show you the color of the ball from which particular bag. Okay. So now since they are all independent events, so this will be white 1 from the bag 1, this will be bag 2, and this will be bag 3, right? So if I just solve this particular case, so white from bag 1, so this is how many balls? 9. So this is 4 by 9 multiplied by white from the bag 2, it is 4 and 3, that is 7, 4 by 7, plus this will be what? Black from this bag, this is 4 by 6. What we can say this again? White from bag 1, black from bag 2, and white from, yes, so again very simple stuff. Now I think you people have got hold of what I am trying to say. So bag 1 white, so again it is 4 by 9 into black. Now from the second it is 3 by 7, right, into again white now 2 by 6. Similarly last one will be black from the bag 1, it will be now 5 by 9, and in remaining 2 you want white, so this is 4 by 7. This will be into, yes, you want white 2 by 6. Just add them to find your answer. So this is your final answer. Okay, so this is a particular question where I have taken an problem and implemented independent events cases to this. Okay, so the next question says, and it is basically a game problem. So you can, if you want to check, this is I called a game problem, very famous one in fact. Okay, a game problem. So what is a game problem? That A and B start playing and they throw a dice. If A throws 6 before B throws 7, then A wins. If B throws 7 before A throws 6, then B wins. As simple as that. So they are throwing a pair of dice. Can you tell me what is the probability of winning of A? So A wins when he throws 6, right? 6. So in how many ways you can obtain 6? It could be 1, 5. Remember, it is a pair of dice. So 2, 4, 3, 3. Then what? 4, 2 and 5, 1. Right? In these many cases you can obtain, that is 5. The probability of A is nothing but what? 5 by 36, which let's say I called as A. Right? Similarly, what is the probability of winning of B? B wins when he throws a 7. So 7 could be obtained in 1, 6, 2, 5, 3, 4, then 4, 3, the reverse order, 5, 2 and 6, 1, right? There are 6 cases, 6 by 36. Let me call probability of winning of A as B as small b. Now you want that they start playing, that means they start throwing the dices, and we start from A, and we need to find the probability of winning of A. So we want probability of winning of A, right? Now how this can be done, let me just show it to you then. The first case is then A starts, he throws, and he gets straight away A, or he gets straight away 6. He wins. B does not even get a chance to play. You can say, sir, no sir, it will not be case. A does not throw a 6. Then you will go to B. B should not win because you want that A should win. Then B also does not throw a 7. And in the second attempt of A shoots a 6. A throws a 6. Some could also say, sir, this will happen when A throws the dice for the third occasion. That means he loses, he does not throw a 6. Then B should not also throw a 7 because otherwise B will win. Then he throws a A. Can you see this? And this can go on till infinity, right? We do not know when this game will stop. This can go on and go on and go on, and they keep on playing. And also interestingly, A and B are independent events. Why? Because they are nowhere related, right? They are independent, as very obvious, because if A throws something, what B throws is completely irrespective of A, right? So I would say this is nothing but A plus what this value would be, A bar into B bar into A, right? This will be what? A bar, B bar, A bar, B bar, A. This is what you can say. Okay, and this process will go on till infinity. This is an infinite series, you can say so. And how you calculate this? Can you say A is common? What you are getting is A bar, B bar here. Can you see here A bar is getting twice and B bar is also getting twice? What will be the next pattern? Yes, A cube and A B bar cube. So this becomes what? This is a infinite GP. Can you see this? This is nothing but infinite GP that is being asked here of you. So what answer you will then say? It is nothing but A into 1 upon 1 minus A bar B bar. As simple as this is the answer we were looking for. And A bar is nothing. What is A bar? A bar is 1 minus A, which we can say is what? 31 by 36. What is B bar? B bar is 1 minus B, which we can say is 30 by 36. Just put the values and solve this. This is how you solve the game problem. This is 5 by 36 into 1 upon 1 minus 31 by 36 into 30 by 36. So this is the answer that you will get, that is 180 by 366. This is the probability of winning of A. In some cases, you could also be asked to find the probability of winning of B. So though if you have solved this, I can quickly say that I have already got the answer of probability of winning of B. This is nothing but 1 minus probability of winning of A. Obviously, because either way, only two players are playing. So either A will win or B will win. So if you have got the probability of winning of A, you can just subtract it from the total probability, that is 1, and you will find the answer. Otherwise, if you were to start from scratch, so you want to find probability of winning of B, so how you will start? Probability A loses and then B wins, because it is given that who starts the game? A starts the game. So you cannot just start from PB, remember. Then the other case would be A loses, B loses, A loses, and then B wins. So this is the series that you will form if you were to ask the probability of winning of B. Okay. Let us now understand the concept of conditional probability. What do you mean by conditional probability? So if A and B are two events related to an experiment, then the probability of occurrence of A under the condition that B has already occurred is called conditional probability, and it is written something like A bar B, and we read that A given B. This is how we read this, and the value for this is nothing but probability A intersection B divided by B. Okay, so this is how a conditional probability works. So how you have to check it here? An event has already occurred. An event has already occurred. It has already taken place, right? Okay, if this has occurred, then find the probability of the other event. Then find the probability of other event. This is what is meant by conditional probability. This is what you have to solve. Okay, so this is where event 1 has already occurred. Now you want to find the probability of event 2 when this has already occurred. This is what is called conditional probability. Just remember the formula of solving this. In fact, if A given B is to be found, and you know that the probability formula is nothing but A intersection B divided by PB, this sometimes can also boil down to number of events common in A and B set and divided by number of events in set B. You can also use this. Okay, so now let's start applying this conditional probability in the question straight away. Now let's take the other problem. It says in a class 30% student fail in maths, 20% fail in physics, and 10% fail in both, right? This is what is given. So whenever these kind of stats are given, so always assume that there are, let's say, 100 students in the class, right? 100 students I can take. Why? Because in this cases, percentages will now reduce to very good numbers. So 30% fail in maths. So fail in maths is how much? Fail in math is 30%. That is 30 students are failing in maths. In physics, if I talk about, in physics you fail 20, so that means 20 fail in maths. 10 fail in both. Both is basically 10. So 10 students fail in both. So this is what is given to you now. So instead of going into percentages, now we have converted this into numbers. A student is chosen at random, then find the probability that he will fail if he had failed in maths. So if just now see the terms, if he has failed, that means it has already occurred. So that is a hint that this is a conditional probability. So if I say event B is fail in physics, right? And if I say declare event A, it is fail in math. What you are asked is probability A given B. That is when the student has already failed in math, already failed in physics, what is the probability that he will fail in? It is nothing but probability A intersection B divided by probability of B. So answer is straight away that we already know that probability A intersection B both is 10%. So that is 10 by 100, which is nothing but 1 by 10. And probability B that he fails in physics. Physics is given to be 20%. That is nothing but 1 by 5. Just put the values. Very, very simple problem. So 1 by 10 upon 1 by 5. Answer comes out to be 1 by 2. This is the answer we were looking for. Let's take another problem. It says in a hostel 60% of the students read Hindi newspaper, 40% read English and 20% read both. Again we'll convert this into a number problem. Let's say there are 100 students in the hostel, right, as we did in the earlier cases also. So 100 students, 60% of them read Hindi. So Hindi newspaper, right, Hindi newspaper is being read by, let's say, 60%, so that means 60 students. English newspaper is being read by 40 and both is being read by how many? Yes, 20%. So this is what is given to you, 20 students. Now again I'll try and convert this into a Venn diagram problem where I'll first of all depict what the question is asking me to do. So this is the Venn diagram in some way where I can say that this is Hindi newspaper and this is the English newspaper and this chunk reads both of them, right? And this outer rectangle is basically the sample space, that is the total number of students, right? It might not be necessary that every student reads a newspaper, right? So this is the sample space, that is 100 students, right, which we have taken converted into numbers. Okay, now let's go ahead and read the problems. Okay, so it says find the probability that a student is selected at random, find the probability that she reads neither Hindi nor English newspaper. So we need to find this particular outside region. Now can you understand that what we are asked to find is this outside region which falls outside all this region, because this region does not read a newspaper completely, right? So how you can find this is, you have 100 students, how many are there in Hindi? So Hindi, if I talk about now only Hindi only. So why I am doing this, because again one region, two region, and this is my third region, let's say. So one region I will say is R1 is how many Hindi reads? Yes, 60 minus 20, that is 40. English only. English only is your region 2, which is nothing but how many students? 40 minus 20. So 20 people who just read English. Both is your R3 region, which is already given to you as 20. So how many has been used? 80 students actually read the newspaper in the campus. That means answer to the first problem is 20 students do not read the newspaper. What is the probability that she does not read? Then it is 2 by 10. So probability that the girl that is selected, the probability that the event will occur is 2 by 10, 20 by 100. Second problem, if she reads Hindi newspaper, find the probability that he reads English newspaper also. So what is given to you in this particular statement? B, that reads Hindi, right? Reads Hindi newspaper. This is already given to you. He reads the Hindi newspaper. You want that he reads English also, right? English newspaper also. So it is a conditional probability game where you want to find that A occurs when B has already occurred. We already know that this is A intersection B divided by PB. Now this can be simply reduced to A intersection B, number of events in A intersection B upon number of students in or events in B section. So A intersection B is how many? Both read 20, right? And what is number of people who study B? That is, what is B? Hindi. Hindi is being read by 60. That's it. So answer to this problem is 1 by 3. That's it. Okay. Similarly, you can solve the third case also. Third case is asking you the reverse of it. If she reads English, find the probability that she reads Hindi newspaper also. So this time round it is probability B by A, right? So probability B by A will again be N A intersection B by, now this time round it will be N A. It is 20 by, yes, you will now use 40. This comes out to be 1 by 2. This is the answer. I hope the question is now clear to you. Now let's take an example, and this example is coming from straight away from your NCERT textbook, and I believe it's a very beautiful example to understand conditional probability. It says, consider the experiment of tossing a coin. Okay, so that means you have tossed a coin. Let me write whatever is given to you. Toss has happened. Obviously, when a toss happens, you will either get a H or you will either get a tail, right? If the coin shows head, toss it again. So if it is head, you will again toss it. That means you will again get a head and you will again get a tail. Okay, this is what is happening. Then it is said if it shows tail, then you throw a dice. Now if this happens, then you throw a dice which could have all the 6 options like 1, 2, 3, 4, 5 and 6. So this is what has occurred. Now what 2 events are given? Find the conditional probability of the event. That the first event is, just name it then. A is the die shows a number greater than 4. Die shows number greater than 4, right? And the B event that is given that there is at least one tail. Okay, so this is what is given. I have just stated what is given in the question itself. What you are asked to find is probability A given B, because it is already said that given there is at least one tail has already happened. That means one tail has already occurred. At least one tail has already occurred. That is the statement given to you. For this, what you need to try and find is number of events which are common to both A and B, right? And the number of events which are in B. This is what you need to find, or you can say probability A intersection B divided by probability B. So now let us first of all define how many events are there happening inside A and inside B. Okay, so for example, if I talk about B event, right? So B event says at least one tail. So what are the options that you people have? Let me just talk about. And since it is a 2-stage event, that let's say this is stage 1, right? Where the first die was tossed, and this is your stage 2, right? So the ordered pair will be of 2 dimension, stage 1 and stage 2. So you want at least one tail. So one tail can be obtained when at the first toss head comes and at the second tails come, right? Then what could happen is tail comes at the first and dice says 1, t1, t comma 1, then t comma 2. Can you understand this? Possible cases are there for, right? This is t comma 6, right? Okay, so these are all the possible cases in set B that you have. And if I ask you what is the probability of event B, since all of these events are independent events, that if this is happening, this is happening, they are nowhere interrelated, right? They are nowhere interrelated. So probability would be nothing but adding their individual probabilities, something like this: probability of head and tail plus probability that t comma 1 occurs, because they are actually rather than saying independent, they are mutually exclusive cases. If this occurs, this will not occur, obviously, right? So they are mutually exclusive cases. All of them are mutually exclusive, right? They will so that means if this occurs, this will not happen. So you just need to add their individual probability. So what is the probability H and T? So at first stage head comes, that is 1 by 2. At the second stage comes head, that is again 1 by 2. So this is nothing but 1 by 4. Okay, then comes the probability that t comes on the first and 1 comes on the second stage. So this is something like this: 1 into 2 upon 1 by 6. Then all the other cases will be similar to this way, right? 1 by 6 is for dice problem. So if you calculate this completely, what you should get here is that 1 by 4 into 1 by 2 into 1 by 6. How many cases are these? These are 6 cases. This gets 1 by 4 into, plus 1 by 2 plus 1 by 2, which is nothing but you will get your answer as 3 by 4 here. So this is the probability of event of B. Now let us also talk about the events which will happen in A. So A, you have to find that die throws more than 4. So die will come only when the single stage event at stage 1 T is there, T5, and you have T6. So these are the favorable cases in stage A. Now you want to find number of events which are in A intersection B. So A intersection B will give you only A again, वापस से वही आ जाएगा, right? So T5 and T6 is nothing but, and what is then the probability? Again, they are mutually exclusive pairs. This and this. If this happens, this will not occur. So you will say probability t comma 5 plus probability t comma 6. What is this answer then? T will come at 1 by 2, 5 will come at 1 by 6, probability t this 1 by 2 and this will be 1 by 6. Why I am saying this? Because inside this particular case they are independent. Inside of this, if I talk about these two events, this is mutually exclusive. If I talk about t comma 6, they are independent events, right? That is why their probabilities are getting multiplied. So what you will get is 2 into 1 by 2 into 1 by 6, which is nothing but 1 by 6. So your answer to this particular problem then would be what? Just now put the value, that is 1 by 6 divided by 3 by 4. This is the answer we were trying to find, and which is nothing but you will get this answer as 2 by 9. Okay, so I hope the problem is clear. It's a beautiful problem to understand the concept of conditional probability, how mutually exclusive they are if we take them on an individual level, and if we go into the depth of one particular case, then they are independent events. How to take intersection, how to find probability, just go through the video once again if you want to make yourself very clear about conditional probability. Then let's understand the other theorem, that is the multiplication theorem. And the multiplication theorem is nothing but it is getting derived from conditional probability only. So let's just go back and check the conditional probability. So it was something of this sort, right? Multiplication just converts this into saying that probability A and B both occur is nothing but probability of B into probability that A occurs when B has already occurred. Obviously you can see that we just shifted it there. This particular thing is known as multiplication theorem, right? Rather than understanding it this way, I like to understand this in this particular fashion. Let's say events are occurring in this fashion: 1, 2 and 3. The first event to occur is number 1, number 2 event, number 3 event. You want that all the 3 events should occur and you need to find its probability, right? So what will happen is, first event that will occur is probability 1, right? Probability first event. Now the second event will occur, but you will say that second event is occurring when already the first event has occurred. Now understood? Then you will say the third event is occurring. Now when is the third event occurring? When 1 and 2 both has occurred. So this is basically what is meant by multiplication theorem. So if you want to find the combination of several events, so this is basically, you can say, combination of several events. So if you want to find combination of several events, probability of the combination of several events, we use multiplication theorem. For this, you just need to find the order in which the events are taking place and then just apply conditional probability each time as you progress to the next stage. So this is stage 1, stage 2, stage 3, and this process can go on. Okay, let's apply the property in a question to understand the concept. So here the question says a bag contains 5 white balls, right? 5 white and 8 red balls are given. So this is the configuration of the bag. It is given that 2 draws of 3 balls each. So 2 draws. So 2 draws, as the name suggests, is a multi-stage event. In stage 1, 3 balls are being drawn, right? If 3 balls are drawn, so what is the configuration left? I don't know, but I know that how many total balls will be left. Initially there were 13. Now net number of balls is 10 balls because it is given it is done without replacement. Then again there is a stage 2 where you again withdraw 3 balls, right? You have again drawn 3 balls. Now the final configuration is that you are just left with 7 balls in the bag. Okay, now what you are asked to find, so this is your first event and this is your second event. What is the probability that the first draw gives 3 white balls and the second draw gives 3 red balls? So stage 1, it is given that 3 white balls are drawn, and at stage 2 it is said that 3 red balls are drawn. So if you want to convert this into your statement purposes, A says 3 white in first draw as is given in the question, right? This is, I am writing the statement from your board's perspective. This is how you need to write at board. And 3 red in second. And now what is being asked of you is that these both events should take simultaneously. So that means you are asked to find A intersection B, right? But obviously, what is the first event that is happening? Yes, stage 1 event. Stage 1 event is A. and then the stage 2 event, that is second row B, occurs only when the stage A event has occurred. So this is what is meant by this. Probability A is very simple to find. What is probability A? Can you tell me? Probability A, 3 wide. So this is the bag configuration till now. So if I draw the configuration of the bag step by step, you have 5 white and 8 red. Then at stage 1, S1, you draw 3 white balls. So 3 white balls are being drawn. So what, in how many ways this could be done? There are how many white balls? 5. So you will select 3. Total is how many? 13. So 13 C3. This is the probability of A. Right. And after stage 1, when 3 white balls have been drawn, what is the configuration left? 2 white, 8 red. Right. This is the configuration. And then you will talk about stage 2, where again 3 balls are drawn which are red in color now. So this is 2 white. So this is the configuration that is happening. Okay. Now let's talk about the second thing, that is probability of B when A has already occurred. So probability of B when A has already occurred. So now you have reached till here. We have taken the effect of stage 1 already in the bag, right? There is now you can see there are only 2 white balls in the bag. So your event A has already taken place and we have counted its value. Now you need to find in how many ways you can draw 3 red balls. So how many total red balls are there? 8. 8 C3 by how many total? Yes, 10 C3, not 13 C3 as we were having it here. So the answer is nothing but just put the values here. 5 C3 divided by 13 C3 into next stage is 8 C3 divided by 10 C3. This is the answer that you people have to give for this particular question. Okay, and this is how multiplication theorem works. It's very, very simple. You just have to consider the effect of stage 1 on stage 2. So you can say effect of stage 1 in stage 2 has to be carry forwarded. That's it. And how this actually happens, generally in most of the cases, I would say the word generally this will change your sample space. Sample space will get changed, right? This is how it will affect the problem. That's it. So now let us understand a very important concept called total probability. Now how I make sure that every student understands the total probability concept is called the algo approach, right? Algo flow. So let's say if I say I start from here, this must be something which computer science students will be able to relate much better, right? When you start, you have multiple options of doing the particular activity. Let's say this is option 1, there is option 2, option 3, option 4 and so on, right? And using this option 1, 2, 3, 4 and so on, you can derive to your net result. This is your net result that you want from the experiment. This is your net result. Okay, so I'll call this result as R. This is the net result R. So this particular chain is that you have obtained result from option 1. This is from option 2, option 3 and so on. Let's say this is option ON. So this path will be called probability O1. This path will be called probability O2, probability O3 and so on. I can go on and keep on writing, right? Probability ON. This path is when result is obtained using O1. So that means you have obtained result R when O1 has already obtained. So you will call this R when, yes, conditional probability. Probability R occurred when option 2 was selected. Probability that result was got when O3 occurred. Probability that result obtained when, yes, similarly all of these. Now the total probability means in how many ways you can, total probability in how many ways you can or obtain the result, right? In how many ways you can obtain the result, or what is the probability of obtaining the result, right? And rather than saying how many ways, which looks like a PNC problem, and what is the probability that you will obtain? So it is nothing but multiplication of all these paths. So you start, so let's say you were here, right? And you want to somewhere reach here, right? So what are the options here? You will reach through this path, you will reach to this path. So all these paths are your options. and this paths which are actually segmented, this path is divided into two, so its total probability will be obtained by multiplying both the paths, right? So the formula then would be, you will say probability of the result that PR will occur will be nothing but probability of the each paths added, right? So this is this particular thing, and this particular thing is actually called as what is called total probability, nothing else, as simple as. So there are n ways, that means there are n paths which you can travel on and then obtain the result. So this particular stuff here is called total probability. This is total probability. So whenever you see a question which is based on total probability, and we will be using total probability in Bayes theorem as well, so you just have to think of the algo flow. What are my options, right? And how we are going to obtain to the result, multiply the path, individual paths, and then add all the paths. That's it. Okay, let's apply them into the problem straight away. So now let's take the first question. It says, for a student to qualify, he must pass at least 2 out of 3 exams. So that means this is the qualifying step, right? So he should pass out of 3, he should pass in 2. The probability that he passes, right? The probability of passing is given to be P. The probability that he passes the exam is given to be P, first exam. So probability of failing then would be nothing but 1 minus P, right? Okay. If he fails in one of the exams, then the probability of his passing the next exam is P by 2. Remember, we did a similar question where we were talking about the motivational factor. So if you get failed, then passing next exam, right? Passing the next exam is not of the same probability P. It reduces to P by 2, right? Let's say due to some motivational factor, you are demotivated, right? And then after you pass, then again the probability will come back to P. Okay, this is the flow of the question. So it asks you in how many ways and what is the probability that you will qualify. So let's start with the flow. Okay, so flow is that you start here and you need to pass 2 out of 3 exams. So how you can do, let's say you can pass first, you can pass second, right? And you can pass the third. This is one of the options, right? You can then have what? Pass here, you can have pass here, and you can have fail here also, right? This will also qualify you for the exam, right? Because 2 of the exams have been cleared. Third is pass here, then you fail at the second, and then you pass at the third. And the other option could be that you fail at the first and then pass at the the third. So these are the total number of ways in which you can actually go on and produce the result. In fact, there is only a single stage method. There is only options, and through options you will get passed, right? This is that you qualify. This is the criteria, right? So let me talk about cases 1, 2, 3 and the 4. These are the 4 cases that you people have. So let's talk about case 1, that you pass in all the 3. That is P, P and P, and passing first exam is the probability P, passing second exam is P, passing the third exam is again P. So this is nothing but PQ, right? Let's talk about the second event. Second event says pass, intersection fail, right? So this will be P into 1 minus P, right? Let's talk about the third event. It says that you pass in the first, but then you fail in the second, then you pass in the third. Remember, these are all independent events, and we are not saying that independent. Why? Because because it is given inside the question. So if you pass the first, the second is irrespective. It is already given. This is pass into fail, but now you are again passed. But if you have failed, then the passing probability is exactly reduces by 2. That is P by 2. Now that is used. Fourth event is fail, pass and pass. So if you fail at the first, so probability of failing is 1 minus P. Then if you have failed, then the next probability of passing the exam will be reduced by 2. That is P by 2. But once you have passed, then the probability of passing again will come back to you. That is P. That is you regain your confidence. And this always added will give you total probability, right? So if you add them all, this is what is the expectation of you. If you can see in all of them, p square is common, right? If I take p square common, what will be left? Let's see, p plus 1 minus p, right? Plus what you will get, p square common, so you will get 1 minus p by 2, and here also what you will get, plus 1 minus p by 2 here. So if you see, what answer you are going to fetch is that this p and p will get cancelled out here, and you will be left with 1 plus 1 minus p. So the net answer that we people were looking for, p square into 2 minus p. This is the answer that you should mark in the exam. So I hope the concept is clear. How we have signified what are options and how we have added them should be very clear in this question. It's very basic question. Okay, so the next question is that x speaks truths in 60% cases and y speaks truth in 50% cases. So this is given that x speaks truth 60% of the times, right? So the probability of speaking truth is 6 by 10. For y, the probability that he will be speaking truth is given to be 50%, that is 5 by 10, that is half the time he speaks truth and half the time he lies. Find the probability that they contradict each other while narrating the same incidents. So the target is that they contradict, right? So when can they contradict? Can you tell me? So let's say there is a statement, right? There is a statement which has which is there, which could be either true or it is basically true or false. So when they can contradict, then when x says it is false, let's say, and y tells you that it is truth, right? This is first contradictory point. Or the other could be that x tells you that it is true and y tells you that it is false. So they in a way are contradicting each other. Okay, and there is no other way in which they can contradict, right? So what if we want to convert this into probability, then it will be x speaks false intersection y speaks truth, so they will be contradicting, plus here it could be x speaks the truth but y is now telling a lie, so they will actually contradict each other. Okay, now just put the values here. It's simple question, so it is nothing but, since they are independent events, so you can just simply do this step, okay, and just put the values. Okay, so this should be y rather than the x component, it should be right. So this will be the particular value, and now you can just substitute the values and the question is over. So x false means 4 by 10, x speaks false or truth, it's basically he lies. This is again 5 by 10, this is 6 by 10, and this is 5 by 10. So this is the answer we guys are looking for, which is nothing but 20. You can just simply add this 20 plus 30 by 100, and in fact if you calculate, so this means there is 50% chances that they will contradict each other. This is what is meant by this particular problem, right? And this is one of those questions which is generally I have seen that being asked routinely in examinations, but it's a very simple problem. In fact, I should not call it a total probability theorem, because generally in total probability theorem we consider 2-tier questions that we did earlier. So single stage event, very simple, just go ahead and do it. Now let's take another very beautiful example which is into use in daily life to understand total probability. It says in a certain city, 2 newspapers A and B are published. 25% of the population reads A, 20% reads B, and 8% reads both A and B. Okay, so this is stage 1. This is given that who all read A, B and both A and B. It is also known that 30% of those who read A but not B look into advertisements. So the target is to look into the advertisements. 40% B but not A look into the advertisement. 50% those who read both A and B look into advertisements, right? This is now a further stage. Stage 1 was who all read A and B. The next stage was who all look into the advertisement, who actually are reading the newspaper. What is the percentage of the population that reads advertisements? So you want to find the percentage of the population which reads actually the advertisement, and this is how Times of India and Hindustan Times derive the rate of their the charges of their advertisements. Okay, so let's start then. We start the flow first of all, right? So at the start you have 3 categories of people who read only A, people who read only B and they read both A and B, right? And you need to target people who read advertisements, right? This is your target, that they read advertisements, right? This is what you need to find. So this, now let's start putting it in the values. This is the flow. So now it is given that probability A, let's start with first of all. So people who read A is given to be 25%. That is 25% is given to be the probability, or you can say we just convert this into 25. So let's say at start we have population is 100, right? We again convert this into number problem. So 25 people read A, but B is given to be what? 20%. So I'll again convert this into numbers, that is 20. And probability A intersection B is given to be 8%. So that means out of 100, 8 people read both. Can you tell me what is probability only A? Probability only A. That will be 25 minus that 8%, that is 17%. Or if I convert this into number only A would be what? 17, right? This is how you should think of. Probability only B will be what? 12%, right? And this is already given. So if you are going by this channel, so let's say this path. So we told you that you always have to select the paths. So these are the paths. So probability, so what you will do, probability only A only, AO, let's write this. Probability BO is means B only, right? And probability A intersection B. Now you have calculated all these three. Now you need to find that people who read advertisement when AO, that AO is there, probability that they read the newspaper when BO is there, and probability they read the newspaper when both the newspaper are being read. Right? This is what is you need to target. So your target would be to find these probability, because this you have already calculated. So this is PAO, this is PBO, and this is PA intersection B. Your target is to find what is the probability that they read the advertisements when they are just reading the A newspaper, which is already given. See, 30% of those who read A but not B. So out of this bag, let's say this is the bag 1, 30% read the advertisement. So this is given to you 30%, right? Probability that they read the advertisement when they are reading newspaper A alone, this is given to be what? Let's see, 40%. This is 40%, and the next event that is going to occur is given to be 50%. So this is 40, right? And the next thing is given to be A intersection B is given to be 50%. So you need to find probability that they read advertisements. So how you are going to write this in the exam is that something of this, probability AO into probability that they read the advertisement when they are already reading only A, something similar to B, right? Probability this, and they read newspaper when B is already read, and probability that they read the newspaper when A intersection B is there into probability A intersection B. So this is what is actually called total probability concept, and you now know each and every value. Just put the values. So probability AO is nothing but 17%. So this is 17. It is 30, right? Now you get my point, what I'm trying to put forward. So BO is nothing but 12%. So this is 12 by 100. This is 40 plus this is 8 by 100 into 50 by 100. Just solve this particular answer. This is what we are targeting to find. Okay, so this is how total probability questions are being used in day-to-day life. Okay, so by this we come to the end of this particular lecture for the day. We'll again continue from the probability tomorrow. Just revise the concept that we have done in the today's class, so that when we start tomorrow, you are much familiar with total probability and the conditional probability concept, because they will be used again tomorrow also. Okay, so I'll see you guys in the tomorrow's video. Till then, good night. Keep learning.